I'm going to spend the next 30 minutes taking you on a fabric journey. So I'm basically going to talk about, deployment of fabrics, how to scale fabrics, different characteristics of a fabric, so on and so forth. So I'm basically going to end up this presentation with a use case for the fabrics. And I think it's a pretty interesting use case that puts more context into what I'm actually going to talk about from a fabrics point of view. So to begin this journey, so this is actually the only marketing slide I have here, but I think this puts some context into what I'm going to present. So we all know that we have pervasive Wi-Fi. We have, lots and lots of IoT devices. I actually read somewhere that by 2023, they kind of expect to have more than 16 billion IoT devices. Now, obviously, some of those IoT devices are going to be wireless, based on 5G connectivity, but obviously, many of them are going to be wired connected as well. And then on the right-hand side, you have the cloud and the hybrid models. So the fabric journey I'm going to take you through is basically reflecting these things. So first thing is, what is a fabric? So the nature of a fabric is basically, how the servers, customers, tenants, whatever you want to call them, connect to each other. And then, obviously, how they do communicate through the network hardware and software. And you are basically looking at fulfilling some key requirements from the infrastructure point of view. Those being agility. Now, the agility thing is kind of, rapid service turn up, add moves, changes, things like that. Availability. We do talk about HA, right? I don't think you need to mention more when you actually talk about availability. That's a given. Then security, I think, is a given as well. I'm not going to spend time on talking on that one because that's kind of the expectation that you have all of these components taken care of. Scalability. Now, scalability goes back to the fact that, I might want to start small, grow to hyperscale. And that's exactly what I'm going to walk you through, how you kind of start with a small fabric, put some context and use cases around that one, as well as obviously understanding that there are specific kind of characteristics with the different fabric types, which would lead into where you put those fabrics. What I mean with that is basically the use cases for the various fabrics. Okay. So, to kind of, introduce, there's a lot of fabrics out there, and you can always argue what is a fabric. I think this first one I have here is an MLAG, an MCT, whatever you want to call it, a two-node layer 2 construct. Is that a fabric? I guess many people in the room might argue with me saying that's not a fabric, that's 2 nodes, right? I think it's still a fabric, and I actually have a valid use case for that. Then you go into specific like data center fabric technologies like Trill. Then you have a variety of the vendor implementations of that. Then you actually go into another fabric type being based on SPB. And then you have some additions or extensions to that. That's something we call Fabric Connect. And in a nutshell, this basically separates the control plane from the data plane. I'm going to cover this fabric kind of more in details, build a use case around that one, why that fabric type might be ideal. And then you go into Mpls. I guess this is the same as the first one with the layer 2 MLAG construct or MCT construct. You could argue, is Mpls truly a fabric technology? I think it is. You do talk about VPLS, you have an overlay, which basically kind of covers the next one, which is the IP fabric, where you also have an overlay being the VXLAN part. So as you can see, there's a bunch of fabrics, and I think I haven't even covered all of those ones. There are even more vendor-specific fabric types out there. The point I'm making here is that there are a lot of different fabrics with different characteristics, meaning that you have different use cases for those. So starting to define these. So I think I kind of covered this one on the previous slide, saying that, you know, a layer 2 construct, MCT, MLAG, whatever you want to call it, it's a 2-node. You kind of go into the next one, which is starting, you know, to build a claw architecture, spine leaf, which could scale horizontally. You could start to add more leaves. Obviously, your limiting factor here is how many ports do you have on your spine node. So how would you scale that then? Kind of vertically. Then you go into a you know, super spine, so you add a layer on top of that one. Now you can scale these both horizontally as well as vertically. So this is just a pick of a couple of fabrics. Excuse me. Now I said you know, if you look at the left-hand side, so that's a layer 2 fabric with given characteristics. That's something you might start to see more in things like the deep edge, the edge cloud, you know, applications like that, because of the characteristics. That one compared to obviously the IP-based fabrics do have different characteristics. Then you go into the Fabric Connect, fabric which, as I kind of in a nutshell defined as being a fabric having an ISIS control plane together with an overlay or a data plane being based on SPBM, which basically provides BVLANs for transport. And not to dig into all the technical, you know, details on these different fabric types, but these are the fabrics I kind of want to put some context around in regards to this presentation. And as I said, the use case I'm going to end up this presentation with. So where do I start? Obviously, there's a lot of factors you need to start to think about when you start to deploy a fabric. So I mean, these are like given many of these. You start to look at your logical design. What is your key applications? Because at the end of the day, the fabric is providing your transport infrastructure. It's providing plumbing basically for your applications, right? Specifically to the data center, obviously you start to look at then the virtualization model. Am I going to you know, have hardware VTEPs, software VTEPs? Now I'm starting to talk about VXLAN. How am I actually going to build out those ones? That's obviously going to dictate in some way your logical design. The physical design, number of hosts that I connect, and that goes back to what I was saying, that how you can scale the fabric, you know, horizontally. Oversubscription. This is a key thing, and this basically goes back to my previous example, saying that you look at the deep edge or the edge cloud. Keep in mind that the edge cloud is defined for 5G, which basically have specific, you know, requirements and characteristics for things like ultra reliable, low latency connectivity. So you can imagine that you know, you need to have a specific fabric type to be able to do that. You don't want to do things like oversubscription. And then obviously the next factor is the external connectivity. Am I going to do DCI? Am I going to do, you know, the border leaf functions, gateway functions, all of those different things. So this is just a high-level list of kind of, you know, walking you through or giving you some examples of aspects you need to take into consideration. Then you go into the automation, and I think the previous presentation was kind of a good one, kind of to talk about automation due to the fact of you know, the human error. Once I start to configure something, I always have a possibility of having, you know, the thick finger, so basically have a configuration glitch, you know, what you configure. So automation is key going forward. And then you start to talk about not only network automation, you might start to talk about, you know, truly the integration or integrating automation into the processes and business applications, which basically means that you start to talk about things like cross-domain automation, where, for example, if I have, you know, a network in place, I have a slow connection, I have a problem in my network, on a user side, on a service side. I might want to do something like remediation. I might actually want to kick off something to analyze the traffic, and then trying to remediate that, as well as have hooks into applications that might be able to kick off a chat message on a NOC channel, as well as kick off or start an application having webhooks into an application like a travel ticket system. So this is where you start to see that this is not only the network automation part, but you start to look at this from a business and application point of view, truly being closed-looped automation, cross-domain automation. So I think I kind of touched on the visibility and analytics in that my previous example. So how do I start to build a fabric? So this kind of goes back to my example of the smallest fabric. This is a scale-out design. You start with 2 nodes. It could be a small data center. It could be multiple sites. So I would actually start to add in more of these 2-node constructs and build it out like this. So keep in mind, this is still a non-CLO architecture. It's a scale-out architecture, which is ideal for starting to build small fabrics and grow. Obviously, I can have my gateway functions connected, as you see here, northbound, and I can have those redundant as well. So basically, you have now a small fabric where you have a gateway function, so everything kind of embedded into a small construct here. Moving ahead on this, obviously the next step would be to go to a 3-stage CLO architecture, where we have the spine and the leaf. So you have the spine on the top, you have the leaves, and you have your border leaves. And as said, the limiting factor on this design is obviously the scale out on horizontally. How many leaves can I add in based on the spine connectivity I have? So that translates into how many ports do I actually have in the spine. So to solve that kind of challenge, the next stage would actually be that you go into a 5-stage CLO architecture, where you basically add in a super spine, which would allow you to have the 3-stage CLO pods, so kind of the squares with the small fabric, or the fabric itself interconnected with the super spine. And obviously the border leaf can be shared between the different parts here. And as mentioned, for the oversubscription, it's becoming even more key here when you start to look at something like this, to make sure that you basically calculate your oversubscription ratio that you would allow in such a design. So, going back to the kind of underlay overlays. So the previous ones obviously was expected to be IP underlays. Now you have obviously the choice of using IBGP or eBGP as the IP underlay, depending on your preferences, depending on characteristics you feel that you want to get from each of those protocols or either of those protocols. Then obviously the overlay network part is the key here, which, as in my kind of introduction, I was talking about, the overlay. Do I want to have hardware VTEPs, software VTEPs, providing basically the layer 2 connectivity, so something called virtual networks. So in this example, you actually have something called a controller-less deployment, where you start to look at the VXLAN, VTEPs, the tunnel endpoints being hardware-based, and those reside on the top of rack switch, as you can see. You can have extensions for layer 2 and layer 3 based on this. And then the next one is that you go with a controller-based deployment, where you basically then, the fabric is just providing the IP transport, while your VXLAN tunnels and the points are within the hypervisor environment, so-called software VTEPs. So these are a high level kind of the difference between these two, depending on your requirements. And as you can see, you then obviously have the same services. Keep in mind that these are layer 2 services, kind of providing paths through your fabric for connectivity. So switching gear here a bit, I kind of mentioned the fourth type of fabric. If you remember the slide I had with the different fabric types, the most right-hand one, kind of saying that that's something called a fabric connect. This is a interesting approach on a fabric type because you do have some challenges obviously with an IP fabric. With IP you have some things like you can trace things, you can fetch things based on IP addresses, you need to deploy ACLs, things like that. Now, looking at this from a status quo point of view, obviously with the IP-based fabric, you might need to provision manually things. It's hop by hop mainly, so on and so forth. But on the right-hand side, you basically have something we call the hypersegmentation or stealth networking. And what this means in a nutshell is basically that from a service point of view, even if I have multiple hops in between, as you can see in the example here, you have video surveillance server, and then you have your camera on the left-hand side. The path, if I do a trace route, if I basically look at the path for the traffic or for the service, it's a single hop due to the fact that you have your edge bridges, your core bridges, which are basically the devices within this fabric. They're completely transparent because of the nature of the SBBM, so basically MAC encapsulation and how this is done. So this is truly an interesting fabric in regards to, as said, hypersegmentation and stealth networking. There are specific use cases for this fabric. And as you can see, the automation for this one obviously happens only at the backbone edge bridge being, the attachment points for your services. Now, that raises an kind of question, okay, so how about, the security aspects of this one? So here's just an example of an IoT device. So say that in this example, you actually have an IoT application. What you see here is that you have 3 devices, IoT devices connected. Assume one of those devices actually disappear from this zone, so to call. That's going to basically automatically delete that given application or device from this zone. And the same applies to if you have any changes. So you have one IoT device moving within this fabric, it's going to obviously then move along as well. Now this is just on a high level. Obviously you have all your access controls, you have all your kind of user controls, everything else associated with this one. But this goes back to my example on the stealth networking. So this is just kind of a high level example of that one. So another aspect, as I mentioned, is automation. And I'm actually going to start to touch on automation now, but something that is worth knowing is that once we start to see more and more devices connected, as I had in my introduction slide, obviously automation at the edge is becoming more and more key. And you have specific mechanisms in place, one being fabric attach, which is actually a standard out there, which would allow you to have things like surveillance cameras, wireless access points, switches, you name it, different kind of appliances or devices connecting into such a fabric. Without the human intervention, you don't need to configure anything because you are basically going to signal an attachment point based on specific criteria. And obviously you have the security part with your control taking care of as well here. But just wanted to mention this, that automation is an end-to-end story. You can't really automate somewhere, it needs to be end-to-end. And this kind of covers that part with fabric attach for a specific fabric type here. So switching gear a bit here and continue on the automation part. So this is basically going to touch on the automation for the fabrics I briefly covered and I started off with. So there's a problem that we are trying to solve. And the problem is basically that network provision is slow, complex, and time-intensive, and obviously subject to errors, as I pointed out, and as was pointed out in the previous presentation as well. So that's the problem we are trying to solve. Now, you have your, basically, you know, virtualization and your hyperconverged infrastructure requirements from the app and server admin, as well as from the network admin part. So what happens is that obviously the guy on the left-hand side talks to the network admin, and he starts to provision, you know, your basic plumbing being the network itself, which basically is your switch interfaces, your VLANs, your routing, you name it. Different aspects of the network part here. And then obviously it might take days or weeks to provision this due to obviously, you know, humans talking to each other and making sure that we get our job done. So this is kind of the problem we are trying to solve. So how are we going to solve this problem? So we are going to solve this problem with something called the you know, EFA, Extreme Fabric Automation, which would allow us to have a central piece being the Extreme Fabric Automation. That's actually the basically interface both for my network admin and my app server admin to start to provision things and orchestrate things. Now, what I mean with that one is that we automate the configuration of not only the infrastructure, but also for the services, being the tenants. So basically you have a single application that, you know, the guys on the left-hand side are working towards to get those things done. And that actually allows us to go into seconds of provisioning compared to the previous example because we automate everything. So to put that into some context, Extreme Fabric Automation, what is that? It's an application. It provides you with day 0 and day 1 automation. Day 0 being basically your infrastructure automation. Day 1 being your attachment points, your tenant automation, things like that. Now, it do actually support multiple topologies. So I was mentioning, you know, the layer 2 MCT construct, the 2-node construct. I was mentioning the 3 and 5-stage claw, and I was mentioning the non-claw architecture as well, or design. So these tools actually do support all of those different topologies. In addition, you have a on-box or off-box kind of architecture around this one. What does that mean? It means that the on-box actually resides on a VM, a TPVM in the switch itself, which means that if I run such an automation application on my fabric itself, it's not going to add any compute overhead because you can run it off-box as well, which means that you need to have a compute to basically run it. So now if you think of a small fabric, a 2-node fabric, and if I need to have a compute, a dedicated compute for that to actually run my automation or my you know, infrastructure day 0 as well as my tenant automation, I obviously add some compute overhead. So instead, I'd like to do that embedded into the fabric using the TPVM on the hardware, the switching hardware itself. We have HA, we have federated services, and obviously these are based on Kubernetes clusters, so you can have multiple of these for HA. And then you go into the kind of expanded capabilities where you have eco partner integration, you have, you know, different validations of the fabrics, things like that. So to kind of put this into some context, what does it mean? So I'm just grabbing here an example of a small fabric where you have obviously your fabric hardware. You have your top of rack switches, your leaves are cabled, you know, as a MCT construct, a layer 2 construct. So basically the next thing you do is you cable up your leaves to the spines, the connections. The next thing you do is you connect your control, the management network. And obviously, you would have your EFA connected to your management network here. The next thing you do is you actually jump onto this application, and you basically have a command where you create a fabric, and as you can notice, it actually defines fabric 1, stage 3. It defines it as a 3-stage claw architecture. And then you define the spines and the leaves for that given topology. And then you basically jump into configuring the fabric. Now, with this command, I basically created my IP underlay. I created all my VLANs, my BGP underlay, my BFDs, you name it. The complete fabric is actually orchestrated and provisioned by this application now. The next thing I'm going to do is, now I have the plumbing taken care of. What I'd like to do is obviously get on to my tenant provisioning. So as you can see, you basically just have a couple of commands where you define the port speed, the VLAN, and an EPG endpoint group for that one. That's where you create your tenants. So as said, you have a single application that can be HA, providing either on-box or off-box support for basically creating the fabric underlay, as well as the overlay, as well as all my tenant provisioning. So this gives you a kind of another picture of the same, obviously, thing, EFA. What you see is that you have a northbound RESTful API, providing basically the ability to talk to any northbound application via RESTful API. Could be any in-house built application, could be third-party application, could be your OSS system, you name it. Then you basically have the ecosystem microservices, which is the integration into various hypervisor environments like OpenStack, VMware, OpenDaylight, you name it. And then you have the southbound device API, which basically talks down southbound to the fabric itself. And then you have the foundation services, which are the asset, fabric, and tenant services. Obviously, the asset kind of looking at the fabric itself from VLAN, so on and so forth. The fabric services being those ones, the asset services looking at then various things there. And then you have the tenant services looking at the attachment points into the fabric itself. So, as you might have guessed, I was pointing to 5G being an interesting use case for this. And today, if you look at the 4G, you only have a few big data centers, right? Now, going to 5G, you are going to have thousands and thousands of micro data centers. So basically, each cell tower is going to have a small data center, which means that you're going to have a fabric basically installed in each and every of those, towers in the small micro data center, which means that going back to the stuff I was kind of touching on, automation, that's key. I mean, if you go to thousands and thousands of these, automation is a must, right? Also, as I kind of pointed out, that there are different characteristics for the fabrics. Now, depending on if you have this in the deep cloud, deep edge, being, as said, the edge cloud. There's so many names for the edge cloud. So probably a layer 2 MCT construct gives you those characteristics due to the fact that you start to talk about things like autonomous driving, right, with, ultra reliable, low latency connectivity, so on and so forth. So I was kind of alluding to having a use case as the last slide here. I think a lot of the fabrics I kind of covered falls into the use case of 5G, and 5G obviously is the thing going forward. So with that said, this is my last summary slide, which basically summarizes this presentation into saying that these are the only network fabric solutions with built-in automation. So I covered a few of those ones. And it's plug and play. So you basically just plug in, as I kind of tried to show you guys on the slide. And then obviously reliable provisioning provides peace of mind. And on the right-hand side, you basically have a Gartner statement, which is pretty interesting to read. Because it basically says that approximately 70% of data center networks tasks are performed manually, which increase the time cost and likelihood of errors and reduce flexibility. And obviously the recommendation is to introduce automation, so on and so forth. Okay, with that said, this concludes my presentation or my Fabric journey for you.